In this video, we're learning how to find the domain of rational and radical functions. And just a quick reminder that the domain is all possible inputs, or x values, for a function. So let's take a look at example 1, which is a radical function because it's under a square root. So we have f of x is equal to the square root of x minus 3. So when we're finding the domain, we want to figure out what x values can we plug in for x and what x values can we not plug in for x. So what we have to remember is that we cannot plug negatives into a square root. So we can't take the square root of -4 or something like that. It's going to give us an imaginary number. So I'm going to write can't have negative under a square root. And this is going to help us find the domain. So when we're finding the domain of something that's under a square root, we're going to take what's under the square root, so x minus 3, and we want to say this can't be negative. So in other words, this has to be greater than or equal to 0. So it can be 0 or positive. And now we're just going to solve this. So we're going to add 3 to both sides of our inequality, and we're going to get that x has to be greater than or equal to 3. And now some teachers will let you leave your answer like that, but I'm going to write in interval notation just in case you need to write it like that. So x is anything greater than or equal to 3. So we're going to put a hard bracket at 3, and then we can go all the way up to positive infinity, and we always put a soft bracket with infinity. So we can write our domain in either of these two ways, and they mean the same thing, which is that x can be 3 or anything above 3. So taking a look at example 2, this time we have f of x is equal to the square root of 3 minus 4x plus 6. So this time we have something added outside of the square root. This doesn't affect our domain. Our domain is only affected by the terms underneath our square root because we can't put a negative under the square root. So we're going to do the same thing. We're going to take what's underneath our square root and say this cannot be negative. It has to be greater than or equal to 0. And now we're going to solve this. We're going to subtract 3 from both sides of our inequality. On the left, we're left with negative 4x is greater than or equal to, and on the right, 0 minus 3 is negative 3. Now we want to divide both sides of our inequality by negative 4. And remember, when you divide both sides of your inequality by a negative, you have to flip the inequality sign. So I'm going to do that first. On the left, negative 4x divided by negative 4 is just a positive 1x. We flipped our inequality sign so it's less than or equal to. And then on the right, negative 3 divided by negative 4 is positive 3/4. So we get that x is less than or equal to positive 3/4. And we can write this using interval notation. So this time x can go anything below 3/4. So it can go all the way down to negative infinity and all the way up to positive 3/4, including 3/4. So we put a hard bracket. So we can write our answer in one of these two ways. Let's go through some more examples. So taking a look at example 3, we have an example of a rational function. So we have an x in the denominator, so our domain is going to be a little bit different. So we have f of x is equal to 3 over x plus 7. And what we have to think about is what can we never put in the denominator of a fraction? Well, we can never put 0. So this can never equal 0. So what we're going to do is just write an equation that says that. So we're going to take our denominator of x plus 7, and we're going to say this cannot equal 0. And we're going to solve this to figure out what values are restricted from our domain. So we're going to subtract 7 from both sides, and we're going to get that x cannot equal negative 7. So x can be anything other than negative 7. Now, again, some teachers will let you just write this, but I'm going to write in interval notation for those of you that need to know how to do that. So basically, x can be anything from negative infinity up to negative 7, but it can't be negative 7. And then it can be anything from negative 7, not including negative 7, up to infinity. So if you want to restrict one number, this is how you write in interval notation. So either way we write it, we get that x can be anything except for negative 7. Moving on to example 4, we have a radical in the denominator. So we're going to have to think a little bit about this one. We're kind of combining both of the concepts we've learned from questions 1, 2, and 3. So because this is in our denominator, it can't equal 0. But because it's in a radical, it also can't be negative. So what we want to say is that 5x minus 1 has to be positive. It can't be 0 or negative. So it's going to be greater than 0. So if it's just in a radical that's in the numerator of a fraction, it's going to be greater than or equal to 0. But if your radical is in the denominator, you have to set what's underneath it to be greater than 0. And now we're just going to solve this. So we're going to add 1 to both sides of our inequality. On the left, we have 5x. On the right, 0 plus 1 is 1. We're going to divide both sides by 5. On the left, we get x. On the right, we have 1/5. So we get that x is greater than 1/5. We're going to write this in interval notation. So we're going to start at 1/5 with a soft bracket because x can equal 1/5. And x can be anything greater, so it can go all the way up to infinity, which always has a soft bracket. So we get that x is greater than 1/5, or you can write in interval notation as 1/5 up to infinity. Let's go over 2 more examples. So in example 5, we have f of x is equal to the square root of 2 minus x over x plus 3. So we have 2 things that are going to restrict our domain. So we're going to do them separately and then kind of combine them together at the end. So first, let's look at this square root. So because the square root is in our numerator, we just can't put a negative under the square root. So we're going to take what's under the square root and say this has to be greater than or equal to 0. We're going to solve this by subtracting 2 from both sides. On the left, we have negative x. On the right, 0 minus 2 is negative 2. And we have to get rid of this negative x by dividing both sides by negative 1. On the left, we have positive x. We divided both sides by a negative, so we're going to flip our inequality sign. And on the right, negative 2 divided by negative 1 is positive 2. So for our numerator, we get that the domain is x is less than or equal to 2. And now we're going to do the denominator. So we know our denominator cannot be equal to 0. So we're going to say x plus 3 cannot equal 0. We're going to solve this. So we're going to subtract 3 from both sides. And we get that x cannot equal negative 3. And now what I'm going to do is just sketch this out so we understand what's going on. So I'm going to sketch this on a number line. So our first domain, and we'll put 2 right here, says that x can be anything below 2. But our second one says that x cannot be negative 3. So we need an open circle at negative 3. And now we want to write this. I'm going to write this in interval notation. So what this is saying is we can go all the way from negative infinity up to negative 3, but it can't equal negative 3. And then we can go all the way from negative 3 up to positive 2, including negative 2. So this is how we can write our domain in interval notation. And finally, taking a look at example 6, we have f of x is equal to the square root of x minus 4 over the square root of x minus 2. So we're going to do a similar thing. We're going to do this in 2 parts. So we're going to look at the numerator, which is the square root of x minus 4. Because the square root's in our numerator, we're going to say what's underneath it has to be greater than or equal to 0. We're going to solve by adding 4 to both sides to get that x has to be greater than or equal to 4. And now in the denominator, we have x minus 2 under our root. Because that root's in our denominator, whatever's under it has to be greater than 0. It can't equal 0 because our denominator can never equal 0. So we're going to add 2 to both sides. So we get that x is greater than 2. And now we need both of these things to be true in order for this function to work. So we're going to graph this on a number line. For the left one, we have that x has to be greater than or equal to 4. So it's going to go this way. And then for the right one, we have that x is greater than 2. And now both of these things have to be true. So we only want to take where they overlap. And where they overlap is right here. I'm going to do it in yellow. So that's going to be our domain. It doesn't matter that the bottom part can be greater than 2, because if we plug in something like 3 into the top part for x, it's going to make the top negative, which we can't have. So our domain is just going to be that x is greater than or equal to 4. And we can write that in interval notation as 4 with a hard bracket up to positive infinity. So hopefully this video helped you guys understand how to find the domain of rational and radical functions. If you want some more practice with problems like these, check out the link in our description for a free practice worksheet.